Hello, and welcome to episode 6 of our series Back to Basics Business Technology Platform. In the previous episodes, we have seen how to store the data. What are the different data movements? What is the governance and why is it so important when we speak about data? Today, what we're going to see is what is a data warehouse, what is a data lake, and other ways of storing and why. We already mentioned several times the multitude of data sources and the variety of data structures existing in large operations. Across the time, the business pushed more and more to have an integrated view of data to transform them into relevant information. For the record, the difference between data and information is the concept of context. Per se, data are meaningless until they are put into a context to provide information. An amount in a database is just a set of bytes representing a number. When put into a context, this number may become a price, an age, or a quantity of ordered product. Originally, the reports were executed over a silo of data and consequently were representing a very restricted part of the business of the enterprise. When people understood the benefit of integrating the silos, they also became interested in providing integrated reports and analysis. Various concepts came therefore into play, like Executive Information Systems, EIS, Management Information System, MIS, Decision Support System, DSS. Having all their specificities, we will not cover here. Across the time, a restricted set of DSS emerged: Data Warehouse, Data Mart, and Data Lake. All of them having a multitude of flavors in the way they are implemented. A data warehouse, sometimes called DWH, also known as an enterprise data warehouse, EDW, is a system used for reporting and data analysis and is considered a core component of business intelligence. Data warehouses are central repositories of integrated data from one or more disparate sources. They store current and historical data in one single place that are used for creating analytical reports for workers throughout the enterprise. The data stored in the warehouse is uploaded from the operational systems, such as marketing, sales, etc. The data may pass through an operational data store and may require data cleansing for additional operations to ensure data quality before it is used in the data warehouse for reporting. A data mart is often seen as a subset of the data warehouse. It is oriented to a specific business function or a single department. This enables each department to use, manipulate, and develop their data any way they see fit, without altering information inside other data marts or the enterprise data warehouse. Various architecture might be defined, from having only independent data marts to having a data warehouse containing data shared by whole enterprise and data marts having data specific to a department or subject. A data lake is a system or repository of data stored in its natural raw format, usually objects, blobs, or files. A data lake is usually a single store for all enterprise data, including raw copies of source system data and transformed data used for tasks such as reporting, visualization, advanced analytics, and machine learning. A data lake can include structured data from relational databases, row and columns, semi-structured data like CSV files, logs, XML, JSON, and unstructured data such as emails, documents, PDF, even binary data such as images, audio, and video. A data lake can be established on premises, meaning within the organization's data center, or in the cloud, meaning using cloud services from vendors such as Amazon, Google, or Microsoft. Clearly, data warehouses and data lakes address different needs and induce a different approach. The first thing to understand is that you do not necessarily know why you store data in a data lake. You only know they might be useful in the future, but you don't know yet what will be the queries over it. Let's take an example with sensor data monitoring the heat of an engine. Maybe you will use them to anticipate maintenance operation, but maybe you will use them to measure the accuracy of the sensor itself. In a data warehouse, you will decide which data to store because you know in advance how they will be used. In a data lake, you do not need to predefine the data structures. You will need to detect them at analysis time to understand how to assemble them and interpret them. In a data warehouse, you do not only model the data structure, you also model its relationships with the other data structures. In a data lake, you keep the data in their original format with no transformation, enrichment, or cleansing, unlike in a data warehouse. If data warehouses and data marts are usually strictly managed and monitored, the data lake concept involves a freedom of storing any type of data from any source, internal or external, as well as freedom to access the data. The first attempts of data lake implementation proved how difficult this openness was to manage. Rapidly, the term data swamp emerged, characterizing a deterioration and unmanaged data lake that is either inaccessible to its intended users or is providing little value. The need of having a well-managed data lake led to the concept of data reservoir. In short, this is a data lake with strong governance framework. Collecting data is important, but it is also important to be able to locate and access the information needed in an appropriate format. Information is valuable. It needs protection. Information is variable in quality. It is necessary to understand its origins and the processing it has had since its creation to understand whether it is appropriate to use. And information has a useful lifetime. It should be removed once it no longer has value. Each of these aspects describes the function of information governance. The data reservoir includes strong governance function, providing people with the trust to share and consume information that is managed by the data reservoir. If data warehousing uses well-proved technologies like ETL or ELT, data lake requires new concepts to orchestrate the data and build data-driven applications. Data orchestration is the automation of data-driven processes from end to end, including preparing data, making decisions based on that data, and taking actions based on those decisions. It is a process that often spans across many different systems, departments, and types of data. When a company employs a data-driven approach, it means it makes strategic decisions based on data analysis and interpretation. The adjective data-driven means that progress in an activity is compelled by data rather than by intuition or by personal experience. A data-driven approach enables companies to examine and organize their data with the goal of better serving their customers and consumers. By using data to drive its actions, an organization can contextualize and/or personalize its messaging to its prospects and customers for a more customer-centric approach. From a data perspective, orchestration will require 6 fundamental characteristics. 1. Landscape management, meaning being able to acquire the metadata of the different data sources is critical to understand them properly. Second, data discovery, meaning being able to discover their values and play with them to understand their quality, is important to determine the data preparation work executed to make them ready for computation. Third, data pipeline. A transformation process must be defined to bring the data in a state applicable to the analysis algorithms using them. This process will use input and output connectors to hub the data, applying various operations onto them in a very open and flexible way. Fourth, orchestrated execution, meaning that when the pipelines are ready to be executed, the orchestration itself starts. The jobs must be scheduled in a workflow we can monitor and analyze. 5. Content lifecycle, meaning across the time the datasets evolve, providing newer or fresher data. The system must be able to access only the very relevant data to avoid manipulating too much information. And finally, access control. Data lake is based on a concept of openness, but meanwhile, as sensitive data might be used, it is still important to provide access control at a very granular level. Many data lake projects do propose an architecture based on a single repository, usually a storage system as cheap as possible, like Hadoop HDFS, Amazon S3, Amazon Web Services, or other cloud vendor, often deporting on-premises data to the cloud to allow the execution of the data science jobs at the risk of less controlling the data access security. Another point is that very often many data are copied to the data lake to allow matching between the operational data coming from the various business applications and the knowledge or IT data. We'll see more of that later. The goal is to allow integrating the complex data science analysis with a business context. This results in a tremendous complex data processing being extremely difficult to manage and will inevitably drive to a lack of trust from the end users. Having a data orchestration technology in place will allow you to access the data from their original sources only when the data-driven application is running, therefore dramatically simplifying the way the data are brought to the data science environment. The impact of this is it will allow to have data science processes become operational, meaning they really help the business in its day-to-day operations. Nowadays, given the explosion of data creation through experience data, such as how do you feel about our company or products or about your experience, etc. Those survey types of data. It is even more obvious that operational data from the operational systems can be hugely enhanced, but duplication of such data, being experience data or operational data, should be avoided. Therefore, orchestration is even more crucial at all points of the data architecture, meaning enterprise-wide. SAP's solution is called data intelligence. Having said all that, now that it's clear what is a data warehouse, what is a data lake, what is a data reservoir, I meet you next time in the next episode when we will talk about the platform itself. Thank you. Bye-bye.